Now the next topic is collinear vector. We know that if vector x is not equal to 0 and vector y is not equal to 0 and vector x is equal to k times vector y, that is a multiple of y, and k is not equal to 0, then vector x and vector y have same or opposite direction, and if two vectors have same or opposite direction, then they are called collinear vectors. These collinear vectors are also called parallel vectors. Because if we express a vector is a multiple of another vector, then it becomes parallel vector condition. So if vector x is moving in this direction with magnitude 3 and vector y has a magnitude 6, then and in the same direction, then it becomes collinear. This is vector x and this is vector y. So these vectors are in the same direction, and if we see, this is vector x with 3 direction, negative 3, and vector y with positive 6 direction, that is this, then they are is in opposite direction. So if vector is a multiple of another vector, then they are said to be collinear vectors. Now next is theorem 6.4. Non-zero vectors x1, x2, which is equal to vector x, vector y is equal to y1, y2 of R square are collinear if and only if x1, y2 minus x2, y1 is equal to 0. Now the proof is vector x and vector y are collinear implies vector x is equal to k times vector y, that is k is not equal to 0 belongs to R, or k belongs to R minus 0. So vector x is x1, x2 plus k times y1, y2. That implies x1, x2, ky1, ky2 by scalar multiplication of k with vector. So by equality law of vectors, we get x1 is equal to ky1 and x2 is equal to ky2. Now we have to check x1 y2 minus x2 y1. So we replace x1 by k y1, it becomes k y1 y2, and x2 by k y2, it becomes k y2 y1. So we get 0. That is if x and y being non-zero vectors are collinear if and only if x1 y2 minus x2 y1 is equal to 0. Now we have to prove if and only part, that is converse. In converse, we have to prove k is not equal to 0 and x and y are non-zero vectors. And this property is hold already. Let x1 y2 minus x2 y1 is equal to 0. That is, we get x1 y2 is equal to x2 y1. That gives x1 over y1 and x2 over y2 by assuming y1 not equal to 0 and y2 not equal to 0. Then we assume x1 over y1 is equal to x2 over y2 ratio is equal to constant quantity k. Now we have to prove x1, x2, they are non-zero vectors. Now if k is equal to 0, then from this x1 is equal to 0 and x2 is equal to 0. That is vector x which is equal to x1 comma x2, that is 0 comma 0 is a 0 vector. But x is not 0 vector, therefore k is not equal to 0. Therefore from above vector x is equal to x1 comma x2, that is k y1 comma k y2, that is k times y1 comma y2, that is k vector y for k belongs to r minus 0 and x is not equal to 0 and y is not equal to 0. Then in this case x and y are collinear. That is, by definition, vector x is equal to k times vector y. And if y1 is equal to 0, y2 is equal to 0, but this is not possible as y is not equal to 0. Therefore, let one component is not equal to 0. So, say y2 is equal to 0 and y1 is not equal to 0. Therefore, given equality x1 y2 minus x2 y1 is equal to 0 becomes, by substituting y2 is equal to 0, we get x2 y1 is equal to 0. So, as x2 y1 is equal to 0 and y1 is not equal to 0 implies x2 is equal to 0. That is, also let as y1 is not equal to 0, then x1 over y1 is equal to k. Therefore, x1 x2 is equal to k y1 comma 0. As x2 is 0, so it can be also replaced as, and y2 is 0, that is, this value can be k y2. Because y2 is 0, so k y2 is also 0. Therefore, we replace here 0 by k y2. So we get k times y1, y2. That is vector x is equal to k times vector y, where k is not equal to 0. Therefore, in this case, x and y are collinear. Now, if we discuss the case, similarly, we can take the case if x1 is 0 and x2 is 0 when k is equal to 0 is rejected because x is not equal to 0 and k is not equal to 0. Therefore, by taking the above case, if one component is equal to 0, and also in this case, we will also get vector x is equal to k times vector y by applying same criteria for all k belongs to r minus 0 and x is not equal to 0 and y is not equal to 0. Therefore, in all cases, we get if x1 y2 minus x2 y1 is equal to 0, this implies vector x and vector y are collinear. So this was all about the theorem 6.4. Now we are going to state the theorem 6.5. That is non-zero vector x and y of R are collinear if and only if vector x cross y is equal to 0. That is, cross product of two vector, outer product of two vector is 0, then two non-zero vectors are collinear. Now we will prove it. That is if and only if, so we have to prove its converse also. Since x and y are collinear, therefore by definition of collinear vectors, we have vector x is equal to k times vector y for all k belongs to r minus 0. That is, k is always non-zero and vector x is always not equal to 0 and vector y is not equal to 0. That is, x and y are non-zero vectors. Now we have to take cross product of x cross y. That is, we replace x by ky cross y. As we know that cross product of two vectors is 0. So we get k into 0 vector, that is 0. So if two vectors are collinear, then their cross product is 0. And now we will prove the converse. In converse, we will take, that is, let x cross y is equal to 0. So by Lagrangian identity, we have x cross y modulus square plus x dot y modulus square is equal to magnitude of vector x square, magnitude of vector y square. As x cross y is 0, therefore it becomes magnitude of x dot y whole square is equal to magnitude of x square dot magnitude of y square. Dot means simple product here. This is 2 into 3 because these are scalar quantities. Now taking square root, we get that is dot product with modulus value is equal to magnitude of x and magnitude of y. So xy Cauchy Schwarz inequality turn into equality, then x is equal to k times y for k belongs to r minus 0, that is k is non-zero and x is not equal to 0 and vector y is not equal to 0. So this is by Schwarz inequality, then they become parallel or they are in opposite direction. That is, if x satisfies y satisfies this equality, then by definition x and y vector are collinear vector. So this was all about our theorem, that is, if we have to prove two vectors are collinear, then take the cross product of these two vectors. If it come out to be 0, then they are collinear.